Okay, I don't know if this is going to work or not, but I'm hoping that maybe I can demonstrate design issues for you using a video game. And so this video game is Car Mechanic Simulator. Yes, it may be a very silly video game, but I believe I can really demonstrate an effect here. So there are 3 cars, 1, 2, 3, and they represent differences in how quick and powerful and other issues related to the car. So this car, according to this game, is called a bolt cape supercharged. It's 8 cylinders and it's supercharged with that big thing on the engine. This car, according to the game, is called a Sakura GT20. It has 6 cylinders. It's nice and sleek, but it has 6 cylinders instead of 8, and it's not supercharged. This third one is a Mazda RX-3. So this is the one car that they've got that's named correctly. Probably somebody at Mazda made this game, or Mazda was willing to pay. In any case, this is a 4-cylinder engine and not supercharged. So just in terms of which car is faster, we would predict that the Bolt Cape would be faster than the Sakura, which would be faster than the Mazda RX-3. Now, there are other factors that you could make the effect bigger, right? And so 8 versus 6 cylinders, that should make an effect bigger. But if you go beyond that and talk about whether or not it's supercharged, that affects other factors. And again, we're going to measure this by racing. So the quality of the tires matter. This game is a game that you fix things up. You'll see here all of these are at 100%. If some of those things were not at 100%, they would perform more poorly. And so even though this car is really ugly in the body area, that is something that shouldn't affect performance. It's non-reactive. Everything within the car is 100%. Okay? So we would predict, if we were to make a prediction, that if we had a single sample T, paired T, or independent T, what would be the question that you would ask to use either one, any of those? So let me give you a paired T. If I had a sample of individuals who drove each of these cars 3 times, and you took the median performance, that you could test whether or not the Bolt Cape performed faster than the Sakura, which performed faster than the Mazda 3. That is single sample, or a paired T, because the same person is going to do all 3 driving. In independent T, you get different people to do all 3. And in the single sample, you would take one of these cars and test it against the population. So you couldn't answer a question about comparisons between cars. It's a single sample T. Okay? So I'm going to drive each of these cars, and we're going to actually test this out. I'm going to pause this while I get one of these to the track. Okay, while it's transitioning to come, so I brought the Bolt Cape. I could have brought any of the 3 cars, but I brought the Bolt Cape. I shouldn't be allowed to choose which one if it's an experiment, but I brought it anyway. Here we go. And so I'm going to drive this 3 times around the track. I'll talk to you as much as I can. But 8 cylinders, we would expect this one to go fastest. And I have good tires. Oh, no! Of course, that doesn't mean that you still drive correctly. Going faster isn't better, so there's an individual difference error factor. And this is why I want to take the average of 3. Sorry I'm not talking more, but you can tell I didn't drive that first round ideally. So, another factor is whether or not you have cognitive load on a task. If I have cognitive load on this task, I'm going to drive as well. 180 kilometers per hour. What is that? It's over 100 miles an hour. Gotta make this turn. I made the turn! Gotta get back off the grass. Grass slows you down. And then another factor. I don't want to jinx myself, but this is not a bad game so far. It does not think I can get it under a minute. So what are we going to predict? 103 maybe? $59. Nice. Alright, we got to make a good turn here. Whoa, no! I have a feeling our 59 is going to be the number we select. We can almost guarantee it now, can't we? Alright, what is it? Worst run we had. Okay, so we'll... Okay, so this is the Sakura, I think it's a Datsun, don't you? Anyway, this is the 6-cylinder. You can probably already tell we're getting off to a much slower start. No turbocharge. I don't know why I had to turn the wheel. Now we're really going to slow down. Woohoo! Trunk driving. No. But, so one thing is carryover effect. So what effect did driving that other car have on my ability to drive this car? Some trouble holding on to the back end. I wonder if I have as good tires on this one. Much better run so far. I'm glad I did not roll that car there. Much better time, 123. But, you know, even as good as that time is, it wasn't even close. I think it was still slower than our slowest time, even when I wrecked twice with the Bolt Cape. Don't be on the grass, slow you down, slow you down. As a kid, I loved playing pole position, so that is the appeal to this game. Is it feels a lot like pole position, but it's got lots of different cars, which gives it a very different experience. Of course, more than two groups, you would rarely use a T-test. I'm talking all of a sudden now. What do we got? How long? $120. So the difference was 20 seconds. Okay, and of course, our third car is the Mazda RX-3. You can expect what's going to happen here. It's going to not be as fast as the Bolt Cape. I wonder though, are we going to be faster than the Sakura, which was so slow. Maybe the fact that this is lighter, it has a little bit. I got better pickup for sure. A bit more control. Well, that certainly seems better than the Sakura, even though it's got a smaller engine. Let's see how well we can go the second time around at 120. Isn't that better than the best one we had? I don't know, 110 maybe. Now, why do you think I go faster the second time every time? Because I'm already accelerated when I start the beginning of the line. No, 112. Not bad. That was perfect time around that turn. What can I bring? How small? Let's see. Make this turn. Don't hit the wall! Alright, here we go. I don't know if I beat that 112 or not. It's going to be close. We got AM, FM radio, no tape deck. 112. 112, 423 versus 438. It's amazing. Alright. And that's it for the driving. So rather than look at me as I wrap this up, I figured it might be a little more fun to watch me drive this thing really fast. So we all drive. We all engage in tasks. We all do things that need to be better or worse or faster or slower. And the question in the class is, if I am looking at performance as a psychological condition and I need to know, did I do something? Did that yield a change? What test do I use? And so if you think about this example and how to change things up, how to ask questions related to performance, and this one is a simple little car game, but think about things in your own lives. Surviving stay-at-home orders, working with children, working within your job. There's so many things that you can develop ideas about and then say, okay, well, how would I design that? Would I have different people do it? And if I had different people do it, what effects would that have? If I have the same people do it, what do I need to control? You know, going from one car to the next car has absolutely impacts the way I perform. Remembering how I did it meant that I performed best on the third trials. And yet I did slowest on the third trials because the third trials had the slowest car. Or the slowest car, but I did better than the car that I should have done on the second. And so you've got issues with order effects if you do repeated measures. And you've got issues with, in between subjects, there's just a lot more variability. Driving this car sometimes is a lot like how it feels to be in this course. It feels like I'm going so fast that if I hit something, I could hurt myself. And yet, it's just a video game. So when I hit something, nothing happens. In this course, if you're feeling stressed, anxious, and like you're moving as fast as this car, take a moment, pause. It'll be all right. What we need to figure out is, when we ask a question, do we use a repeated measures design, paired t-test, or an independent, between subjects design, independent t? Or are we just comparing the sample to an overall group, one sample t? I'll see you in another video.